Good morning, dear learners. Welcome to Teaching Learning section. Today we'll discuss about data processing. In our last lecture, we discussed about various measurement scales, whether it's attitudinal measurement scales or other scales. We discussed about the questionnaires, how to develop the questionnaires. We discussed about the sample design, what is sampling, types of samples. Today, we'll discuss about data processing. What is data processing? After deciding about the sample, after deciding about the population and taking out the sample size, estimating the sample size, we collect the data from those samples, either in form of interviews or through questionnaires. And whenever we get the data, it is very important to process that data. Then only we can utilize that data. What is data? Data is raw facts and figures are known as data. And when we process that data, then it becomes information. And information is used to take the decisions. So data processing is very important. Data processing is converting the raw facts and figures into usable data so that we can utilize that information. Whenever we collect the data, it is very important to edit the data. Editing of data is the process of examining the raw data to detect error and omissions. Whenever we collect the data, there could be chances of errors. Errors like what errors? Errors like someone has given more than one answer for a single question. Someone might not have given any answer for a given question. Omissions. It depends on the researcher how to edit that data. If there are errors, how to correct that data or to discard that data. And ensure the completeness, consistency and accuracy and homogeneity. After editing the data, why editing is required? Your data should be complete. If someone has not given the answer to the given question, then how can you evaluate that question? How will you evaluate that answer? So your data should be complete. There should be no null value. If there is null value, how to edit that null or missing value, that depends on the researcher. If there are more than one response for a given question, which response to consider? Your data should be consistent. There should be no inconsistency. If there are more than one data, more than one response, this makes the data inconsistent. Your data should be accurate. Then only you will get the correct data, and your data should be homogeneous. And this editing of data helps in coding and tabulation of data. Editing involves a careful scrutiny of completed questionnaires. Whether every respondent has given answer to all the questions. Has anyone given more than one answer to the question? Or someone has left few questions unanswered? Is there any inconsistency in the questionnaire? So this editing of data helps in scrutiny of complete questionnaire. And through this scrutiny, one can analyze the data. This editing of data is done at two levels. First is field editing and second is central editing. What is field editing? Field editing consists of review of reporting form by investigator for completing or translating what that data has written in abbreviated form at the time of interviewing the respondent. Or in simpler terms, if I say, if someone is if someone is in the field and getting the respond and getting the responses from the respondent, then the field then the surveyor who is in the field checks out whether everyone has given the right answers, whether I will not say the right answer, that is not the correct term, whether everyone has answered all the questions. Is someone facing any of the problems in the questionnaire? Is there something which is ambiguous and need to be explained to the respondent? All this is done by the surveyor in the field. When surveyor is in the field, he edits the data in the field itself. He or she looks whether everyone has answered all the question. Is there any ambiguity in the answers, or is there anything in which a respondent is finding difficulty? This is known as field editing. And next is central editing. Central editing carried out when all the forms of schedule have been completed and returned to the headquarters. When all the data which has been collected from the various field has been returned to the headquarter, and the type of central editing requires that all forms are thoroughly edited by a single person in a small field study or a small group of a person in case of a large field study. When all of the fields when all of the questionnaire return to the headquarter, then the editor or the researcher is the one who edits the data, who edits the data of all the forms thoroughly. It could be done by a single person in case of a small data size, or it could be done by a small group of people in case of a large sample size. So field editing, when a surveyor who is in the field edits the data there and then in the field, then that is known as the field editing. Central editing, when the field questionnaires return to the headquarter, the researcher or the editor is the person who edits the data, who edits the questionnaire thoroughly. It could be done by a single person or a group of a person, that depends on the sample size. After editing the data, there should be a coding of data. What is coding of data? Coding is nothing but assigning the symbols. It could be alphabetical or numerical or both to the answers, so that responses can be recorded into a limited number of classes or categories. Suppose I have divided my sample into two classes or categories, male and female, and I have coded male as a 1 and female as a 2, so that or other genders as a 3, right? So there are 3 categories in which my data has been classified or divided, and this is known as coding of data. Coding is assigning symbols, either alphabetical, numerical, or both alphabetical or numerical, to the response, so that the responses can be recorded in a limited number of classes or categories. There should not be unlimited number of classes or categories. The classes should be appropriate to the research problem being studied. Whenever you are classifying your data into classes, it should be according to your research problem. It should be with reference to your research problem. They must be exhaustive and must be mutually exclusive, so that answer can be placed in one and only one cell in a given category. Mutually, that is exhaustive, and mutually exclusive means that that response should fall in either of the categories, either in category 1 two or three, there should be no response that can fall under more than one categories, either male or a female or a transgender or other genders. If there are three categories, it should be mutually exclusive and exhaustive, so that your answer should fall under one category only. Then only you can get the correct results. So assign, while you are coding your data, assign signs and symbols in a way that makes your data mutually exclusive and exhaustive. The coding is necessary for efficient analysis of data. Coding decisions should usually be taken at the designing stage of questionnaire, so that the likely responses to questions are pre-coded. Whenever you are making the categories or whenever you want to code something, it should be done, it should be pre-decided. It should be decided while you are developing your questionnaire, so that you can develop your questionnaire and can record your answers accordingly, so that your questions could be pre-recorded. So if you want to divide, or if you want to make categories for your data, it should be pre-decided. It should be decided at the stage of preparing a questionnaire. Classification of data. Voluminous raw data collected through a survey need to be reduced into homogeneous group for any meaningful analysis. When you get exhaustive responses, then it is very important that you should divide or you should reduce your data into homogeneous groups, so that you can meaningfully analyze the data. Classification of data is process of arranging a data in groups or classes on the basis of some characteristics. What is classification of data? Classification, that is division of data. Arranging of data. Arrangement of data in groups. On what basis? On the basis of some characteristics. These characteristics or attribute could be anything. It could be income, it could be age, it could be gender, or it could be something else. So classification of data is process of arranging the data in groups or classes on the basis of some characteristics. Classification can either be according to attributes or according to the numerical characteristics. In case of classification according to attributes, means according to characteristics, the data is classified by descriptive, that is, it could be on the basis of sex, it could be basis of caste, it could be basis of education, it could be on the basis of income level, or it could be on basis of land holding, or it could be on basis of age or anything else. The descriptive characteristics refers to the qualitative phenomenon which cannot be measured quantitatively. Only their presence or absence as an individual item can be observed. In case of simple classification, also referred to as classification according to dichotomy. So you can classify your data on the basis of dichotomy. Dichotomy means either two responses, either yes or no, male or female, educated, uneducated, or smoker, non-smoker. So simplest classification is on the basis of a dichotomy, right? Manifold classification, when more than one attributes are considered, and therefore the classification leads to formation of number of classes and subclasses. The simplest form of classification is dichotomy, that is, on the basis of two you have to choose one, either this or that, right? But manifold classification, when there are more than one attributes, male, within the age group of say 25 to 30, income should be between 50,000 to 1 lakh rupees. Then this classification leads to formation of number of classes and subclasses when there are more than one attributes to be considered. When individual observations possesses numerical characteristics such as height, weight, marks, etc., they are classified on the basis of class intervals. So the first one is classification according to attributes. It is descriptive type of classification. Only their presence or absence could be observed. Second type is when individual possesses numerical characteristics such as height, weight, marks, incomes, and it could be based on the class intervals like age group between 0 to 10, then 10 to 15, 10 to 20, 20 to 30, 30 to 40, right? Or marks between 0 to 40%, 41 to 80%, then 81 to 90%, 99%, and 99 and above, right? So it could be, it is on the basis of the class intervals. Statistical series. Another is, what is statistical series? A series defined as logical or systematic arrangement of observation of items. It is very important you should understand all these things, because then only you can arrange or code your data, and once your coding is correct, then only you can apply the test and get the results, right? So statistical series, the series is defined as a logical or systematic arrangement of observation or items. Either it could be in ascending order or a descending order, or it could be in any of the order, but there should be a logical order. There should be a systematic arrangement of observation or items. When attributes or things are counted, measured, or weighed and arranged in an ordered manner, say ascending or descending, they constitute a series. Right? When there is a systematic arrangement, it could be ascending or it could be descending, then this systematic arrangement is known as series. When statistical data pertains to time, the series is said with a historical time series. The important factor in such series is chronology. When this series is related to time, then this is known as historical time or historical or time series. When the data pertaining to space, the series is referred to as the spatial and is also known as geographical series. And when data refers to the physical conditions such as height, weight, age, etc., then this is referred to as condition series. What is series? Any logical arrangement of the data either in ascending or descending order, then that is known as series. The series can be classified as an individual observation, discrete series, or continuous series, right? So series could be of individual observation, discrete series, or the continuous series. In case of series of individual observation, the items are listed singly as distinguished from listing them in a group. Whenever it is an individual observation, the items are listed singly. While in the discrete series, items are arranged in group, that is in frequency, showing a definite break from one point to another and are exactly measurable. Suppose, let me explain it with an example. There are the marks 10, 20, 30, 40, 50, and 60. 7 students scored 10 marks in a test, 8 scored 20, 6 scored 30, and 5 scored 40 marks, and only 2 students scored 50 marks in a test. So this is a discrete series. Discrete series items are arranged in a group frequency distribution showing a definite break from one point to another. There is a definite break from one point to another, 10, 20, 30, 40, 50. There is a definite break from one point to another. And there is an exact, and this is exactly measurable. There is an exact measure between 10, 20, 20, 30, 30, 40 and 40, 50. Then this series is known as discrete series. Discrete series, when it is divided into group, that is the frequency distribution. Frequency distribution, as I said, that 8 scored 10, 9 scored 20, 7 scored say 30 and 5 scored 40 and 2 scored 50. So this is frequency distribution, and there is a definite break from one point to another and is exact measurable. While in continuous series, the items are arranged in class and they can be arranged either in ascending order or descending order of magnitude, and their continuity is not broken. That is what is continuous series. Continuous series, the items are arranged in a class, that is say income between 0 to 1500, then 1500 to 3000, then 3000 to 4500, 4500 to 5500, then 5500 to say 7000, right? So in case of continuous series, the items are arranged in a class and they can be arranged either in ascending or descending order, and magnitude of their continuity is not broken. That is 0 to 1500, then 15 to 3000, 3000 to 4500, 45 to 6000, right? So continuity is not broken and they are arranged in either in ascending or descending order, then that is known as continuous series, and they are arranged in a class. So I hope this is clear. Statistical series. Statistical series is systematic arrangement of observation, and it could be measured either in ascending orderly manner, ascending or descending, right? And there could be these are classified as, these series could be classified as individual observation, discrete series or continuous series, right? Now table as data presentation device. Now it is very important. Table is a very important device which presents the data. The tabulation is used for summarization and condensation of the data. It aids in analysis of relationships, trends, and other summarization of a given data. The tabulation may be simple or complex. What is the tabulation of the data? Tabulation of the data, when you present the data in a tabular form. That is when you summarize. This tabulation is used for the summarization of data, right? How it helps? It helps in analysis of relationship. It helps in analysis of trends and other summarization of given data, right? Suppose if I want to present data, if I want to present the data of two companies, if I want to present the profit data of two companies for say 5 years, right? From 2000, from 2005 to till 2010 of a company A and of a company B, then I can present it in a tabular form. 2005, the profit of company A is X, 2006 Y, 2007 Z, 2008 A, 2009 B, 2010 C. Similarly, in another table, I can show the profits of a company B. Right? So tabulation could be simple or could be complex. There are certain characteristics of tables which, or characteristics of a table, or there are certain do's and don'ts while you are presenting your data in a tabular forms, which you should consider while while presenting your data in a table. That is, every table should have a clear and concise title to make it understandable without reference to text. There should be a heading for each and every table. It should be self-explanatory. There should be no need to go through the text of the table. The title should always be just above the body of the table so that anyone can make out this is the profit table of company A, or the comparisons of company A on the basis of profit, right? So every table should have a clear and concise title, and it should be at the top of the table. Every table should given a distinct number of facilitate easy references. There should be references for each and every table. Every table should have a caption. That there should be a column heading so that one can understand this column represents what, like serial number, year, profit, loss, balance, right? So every table should have a caption, that is the column heading, and stubs, that is the row headings, and they should be clear and brief. The units of measurement used must always be indicated. If there is any unit of measurement, it should be indicated. That is profit is in thousands or in crores, or population. If you are representing a population of any country or of any city in a tabular form, and if you are comparing something, then it should be that a measurement should be, the units of measurement should be indicated. Like if you are measuring the height, whether it is in centimeters or in inches, it should be written, it should be mentioned, it should be indicated in the table, whether this height is in inches or in centimeters, where it is in kilos or logs, right? Sources or source from where the data in the table have been obtained must be indicated at the bottom of the table. The title of the table should be at the top of the table, and the sources from where you have taken that data must be written at the bottom of the table. Sources, if you have created that table, then it should be source researcher, or if you have taken any data, say from RBI site, then mention the site. Or if you have taken the data from any journal, then mention that the name of the journal. The source or the sources from where data table have been obtained must be indicated at the bottom of the table. Explanatory footnote, if any, concerning the table should be given beneath the table along with reference symbol. If you want to give any footnote about the table, then it should be given as a footnote, explanatory footnote. If you want to explain more about the table, then it should be given at the footnote. The column in the table must be numbered to facilitate the reference. Abbreviation should be used to a minimal possible extent. Yes, it is very important. If you are using any abbreviation, it should be of minimal. You should use it at the minimal possible extent. Try to write the full forms rather than the abbreviation, because at times it becomes difficult for a reader to remember those abbreviations if there are many abbreviations, and then eventually the reader loses interest in reading that table. That table should be logical, clear, accurate, and as simple as possible. The arrangement of data categories in table may be chronological, geographical, alphabetical, according to magnitude of the facilitate comparison. If you are arranging the data, it should be in a chronological order. It can be in geographical order or alphabetical order or the numerical order. There should be a proper order. You should follow a proper order, right? You should not put any of the thing anywhere. If you are following any alphabetical order, follow the alphabetical order. If you are following any chronological order, say on the basis of the years, right from 2001 to 2010, then it should be in the chronological order. It should be either in ascending order, it should be in descending order. It depends on you. But there should be a proper order. Proper order should be followed in the table. The table must suit the needs and requirement of the research study. Do not involve or include any table which is not required for this study. Include all the relevant data and table in your study. Graphical representation of data. After presenting the data in tabular form, then another important thing is presentation of data is in the graphical form. What is the graphical presentation of data? Several types of graphs or charts are used to present the statistical data, like bar chart. You can use the bar chart, pie chart, two-dimensional diagrams, pictograms, arithmetic charts, and line charts, and it gives an idea about the data. Bar charts, when you want to compare the two-dimensional diagrams, or the pictogram or the pie charts, give you the idea what is there in the data, right? So I hope this coding is clear. It is very important while you are coding a data. Your data should be, while you are after collection of data, you should code your data. Coding should be done at the field level or at the central level, right? Then your data should be arranged in a logical sequence, in a particular order. It could be either ascending or a descending, or either it depends on you which type of order you choose. Then present your data in a tabular form. There are certain do's and don'ts when you are presenting your data in the tabular form. We discussed about that. The few very important do's and don'ts is there should be a clear mention about the table. There should be the title of the table at the top of the table. The source should be presented at the bottom of the table. Column should be properly given the numbers and the headings. Row should be given the proper numbers. Data should be clear, concise, to the point. And if there any measurement unit has been used, you must indicate those measurement units somewhere in the table, right? If you want to describe more about the table, use the footnote. And apart from the tabular presentation of data, another is graphical presentation of data. You can present your data in a graphical mode. It could be through the line chart, pie chart, bar diagram, or two-dimensional diagrams, right? Now, statistical analysis and interpretation of data, non-parametric test. Today we'll discuss about the non-parametric test. See, after collection of data, after coding that data, why we code the data? We code the data so that we can carry out statistical analysis on that data. And after carrying out that statistical analysis, we can interpret the data, right? There are various types of tests we can conduct. Statistical test we can conduct on our data. It could be the parametric test or it could be non-parametric test. Today we are gonna to discuss about the non-parametric test. But what is it is very important you should understand what is parametric test and what is non-parametric test, right? Parametric test, what are parametric test? Assumes a parameters such as mean, standard deviation, etc. exist and they are used to develop a test. Why we are carrying out a parametric test? In parametric test, there are certain parameters. We assume that there are certain parameters like mean, like standard deviation, and on the basis of these parameters we develop a test. For example, t-test, right? When we want to compare the means of two population, right? Then parametric tests are developed, right? That is when we want to compare the mean, then it involves parametric test because there are certain parameters such as mean and standard deviation, right? The parametric tests are developed with assumption that the form of population distribution was known. See, there are few important things which you should know about the test. What difference between the parametric test and non-parametric test? Parametric test assumes that parameters such as means and standard deviation exist, and a test depends on these parameters. The second thing, there are certain assumptions to carry out parametric test. If those assumptions are met, then only you can carry out your parametric test, right? The one of the assumption is that the form of population distribution was known. That it is known that the population distribution was known to the researcher, right? Then only if the population distribution is known to the researcher, then you can carry out the parametric test, right? Test the hypothesis which deal with population parameters are called parametric test. There are situations. See, if you know the distribution of population, then you can carry out parametric test. But there are situations, especially the psychological situation or in market research, where the basic assumption underlying the parametric test are not valid, and one does not have knowledge of distribution of population parameter being tested. Then how to carry out the research? How to analyze the data? When there are when assumptions there are particular conditions when the assumptions are not valid. You cannot say whether people will like this packaging of the product or not. You launched a new product and you want to know about the liking of consumer about the packaging of that product, whether people like the packaging of that product or not. Then there are the chances that the distribution of population is not known to the researcher, or assumptions are not valid. In those cases where assumptions are not valid or the distribution of population is not known, then you carry out a non-parametric test. The test which handle problem of these types are known as non-parametric test or distribution-free test. These tests require no or less restricting assumption than corresponding parametric test. See, whenever you carry out parametric test, there are certain assumptions. When you carry out t-test, there are 3-4 assumptions which should met. If those assumptions met, then you should carry out your t-test. Otherwise, go for non-parametric test. Non-parametric test, there is no or the less restriction about the assumption, right? These tests are more suitable for analyzing ranked, scaled or rated data. When your data is rated or when your data is ranked, right, or scaled. In our last lecture, we discussed about the scales: ordinal scale, nominal scale, right? And we discussed about the ranked scales, right? Give ranking, give your preferences from 1 to 5. When there are things like that, right? When these non-parametric tests are suitable for analyze the ranked, scaled or rated data. And these non-parametric tests involve few arithmetic computations. Basic assumption about the parametric tests are valid. The non-parametric tests are less powerful than parametric tests. Yes. If there are certain pros about the parametric test, there are cons of parametric and non-parametric test, right? In non-parametric test, you can carry out non-parametric test when your assumptions are not met, right? Non-parametric tests are not very rigid about the assumption, but again, these non-parametric tests are not as powerful as parametric test. It is difficult to generalize the results of non-parametric test. You can generalize the result of parametric test, but it is difficult to generalize the results of non-parametric test. They are less powerful than the parametric test. There is a greater risk of accepting the false hypothesis and thus committing the type 2 error. We discussed about the type 1 error and type 2 error. False positive and negative. False positive and so there are the chances of type 2 error. That is accepting the false hypothesis. When hypothesis is not correct, again you are accepting the hypothesis. In non-parametric method, the null hypothesis is somewhat loosely defined. Thereby, when the null hypothesis is rejected, the non-parametric test yield less precise conclusion compared to parametric test. It means you cannot generalize the results because hypothesis is loosely defined. When should you use these non-parametric tests? In consumer behavior survey, as I have given you the example, for a new packaging design, the response are not likely to be normally distributed, but clustering around the two extreme position with very few respondents giving a neutral response to the packaging design, like either they like it or they don't like it. These are the two extremes, and very few will say no comments. Sometimes the response to a questions are given in terms of names, which cannot be treated as number. Right? For example, if you ask a young graduate in which part of the country would you like to take up the job and live, your reply could be north, east, west, northwest, or south, etc. The nominal data can be analyzed only by non-parametric test. Parametric, you cannot carry out parametric test on this. On the nominal data, you cannot carry out the parametric test. Non-parametric test used to provide a reasonable good results even if very small samples. If your sample size is very small, then even you can carry out your non-parametric test. One sample test. The one sample test are used to answer the questions such as, is there a significant difference the observed and the expected frequency? Is it reasonable to believe that a sample has been drawn from a specified population? Or is it reasonable to accept that sample is random sample from some known population? Right? And if these are the questions, like, is there significant difference between the observed and expected frequency? Whether the sample is drawn from whether the sample is random sample, or is it reasonable to believe that the sample are drawn from a specified population, then the test which used to obtain the answer of the above question is test for goodness of fit. What is this test for goodness of fit? We'll discuss about this. Before that, we'll discuss another test, that is KS1 sample test, that is Kolmogorov-Smirnov one sample test. Kolmogorov-Smirnov one sample test, it is also known as KS test. This KS test is used for comparing the distribution on an ordinal scale. The test is concerned with degree of agreement between the distribution of observed value to some specified theoretical distribution. See, there is a given specified theoretical distribution, and when you compare the observed value with that specified theoretical distribution, then only you can analyze that whether there is a significant difference or not. It determines whether score in a sample can be reasonably be thought to have come from a population having a theoretical distribution. Right? There is a given there is a specified theoretical value, and when you compare your observed value with that theoretical value, then you can analyze whether your data has come from a population having the theoretical distribution or not, right? Chi-square test, this is one of the very important non-parametric test. Chi-square test of goodness of fit is used to test whether the significant difference exists between the observed number of responses to the expected number based on the null hypothesis in each category or classes. Suppose we have divided our data into 3 classes, right? And chi-square test or test of goodness of fit is used to test whether our expected value, suppose we want to check, we have 3 colors A, B and C, right? And we want to check out we want to know which color the people like most. According to us, we have a sample of say 30, 90, and according to us 30 people will like A, 30 will like B, 30 will like C, right? This is our expected value. Now we want observed value. When we ask from the people whether you like A, B or C, then the numbers which comes out after collecting the data, then that is known as the observed value or observed number, right? So goodness of fit is used whether the significant difference exists between the observed number of responses and the expected, depends on the null hypothesis. The formula to calculate the chi-square value is chi-square is equals to summation from ith element from 1 to k. 1 to k is sample from 1 to k. If suppose I have taken a 90 sample, that from 1 to 30, 90, whatever the sample size from ith to k, and observed value minus expected value, square of observed value minus expected value divided by the expected value, will get the value of chi-square. OI and EI are the observed and the expected frequency. In the ith class, there brings up k classes. The low value for chi-square means that there is a high correlation between your two sets of data. Suppose my null hypothesis is that there is a no correlation or there is a no significant difference between the class A and the class B, and there is no significant difference in liking of colors between A, B and C, that equal people likes all the colors, right? There is no significant difference in the liking of the colors, right? And how can I find out? Through the chi-square value, I find out whether there is a significant difference or not. The low value of a chi-square means that there is a high correlation between the two sets of the data. Calculate the chi-square value and compare it to the critical value of chi-square table. See how to find out the chi-square value. We calculate the chi-square value using this formula OI minus EI whole square divided by EI square, right? Then we compare it. Then we compare this chi-square value to a critical value from a chi-square table. There is a chi-square table and there is a critical value of a defined degree of a freedom, and we compare it to a critical value from a chi-square table. If the chi-square value is more than the critical value, then there is a significant difference. If the value of chi-square is more, then there is a significant difference. Null hypothesis rejected. If chi-square value is less than the critical value, then there is no significant difference. For any given level of significance, calculated value of chi-square is greater than the critical, then hypothesis is rejected. If chi-square value is more than the critical value, right? Then null hypothesis rejected. It means there is a significant difference. That's what I have written. Let me explain it with an example. My null hypothesis is there is no difference between the observed and the expected value. Any difference detected is due to chance. There is no significant difference in the expected and the observed value. Alternate hypothesis, the observed and expected values are different and the difference is statistical significant and not due to the chance. My outcome is I have taken a sample of 6 observed and expected value. I have recorded the observed and the expected value. My observed value for record 1 is 0.03 and what I expected was 0.053. For 2 is 0.17 observed value, expected is 0.136, 0.23 and 0.218 for third and so on. It goes on. So I have observed, I have recorded the observed and the expected value. Now what to do with this? I want to calculate the chi-square test, or I want to use the chi-square test at 5% significant level or confidence level. I want at 95% confidence level, I want to determine whether the other frequencies are different, that is the observed frequencies are different from expected frequencies or not. Right? I'm 95% confident that there is no significant difference. I want to test it out. So state the null and alternate hypothesis. I have done that. Right? That is no difference between the observed and the expected frequency of outcome of the rolling dice, or there is a difference. Then at significant level is 5%, that is at 95% significant level. Degree of freedom is 6 minus 1. What is degree of freedom? Degree of freedom is this number minus 1. K minus 1 is degree of freedom. Right? Class, that is classes, ith class, that is I equals to 1 to k, yani 1 minus k. If the number of classes minus 1 is degree of freedom, in this there are 6, so 6 minus 1 is 5, so degree of freedom is 5. Corresponding chi-square value is 11.07. I have written it there. You have to check it in a chi-square table at 95% confidence level or at 5% significant level. The value of chi-square value at degree of freedom 5 is 11.07. I mentioned it here. Otherwise, you can check it. You have to check it from the chi-square table. Now, I applied the formula here. This is my expected, this is my observed, this is my expected value. OI minus EI, it comes out to be this. Then square of OI minus EI, it comes out this. And then I applied the formula OI minus EI square divided by EI. Then it comes out, right? I have observed the values in the last column. Right? Chi-square is equals to summation of I from 1 to k, right? And OI minus EI square divided by EI. Now I summate 0.0998 plus 0.085 plus 0.006 plus 0.0083 plus 0.0014 and so on, and it comes out to be 0.1186. Value of chi is 0.1186. So now I have the value of chi-square test, right? And the corresponding value of chi-square value is 11.07, right? That is at 5 degree of freedom at 95 confidence level. The critical value is 11.07 and chi-square value is 0.1186. So now I have a critical value, now I have a chi-square value, and chi-square value is 0.1186 is lesser than 11.07. So we accept the null hypothesis. That is, there is no significant difference. That's what I told you at the beginning. If chi-square value is more than the critical value, then there is a then there is a significant difference, right? And the here this is chi-square value is less than the critical value, so there is no significant difference. If it would be more than 11.07, if it is, say, if it is 12.11, then there is a significant difference, then we would have rejected the null hypothesis. The value of chi-square is 0.1186 and the critical value is 11.086, which is less than the chi-square value. Chi-square value is lesser than the critical value. This shows that there is no significant difference, right? I hope this is clear. Okay, another example, that is test for independence. Number of variables, I have number of variables 2 used to determine whether the variables are different or same, and degree of freedom. The observed table and the expected table, that is, suppose I have taken a 1,000 samples of men and women who voted and not voted. Then my observed values for the men who voted are 2792 and women are 3591, while not voted men are 1486 and women are 2135. Expected values were 2731, 1547, 3652 and 2070 respectively, right? So significance level and degree of freedom, I want to check it at 95% confidence level or at 5% significant level. Degree of freedom is what? I minus k here. This is, there are two classes, men and women, so 2 minus 1, right? And voted and non-voted, then again two classes, 2 minus 1. 2 minus 1 multiplied by 2 minus 1. 2 minus 1 comes out to be 1 and 2 minus 1 comes out to be 1. So 1 multiplied by 1 is 1. So degree of freedom is 1. That is k minus 1. The k is what? Number of classes. Here number of classes are 2, men and women, and another is voted or not voted, right? And the corresponding chi-square value is 3.84. The chi-square value at 5% significant level is 3.84. Now I have calculated the value of chi-square and it comes out to be 6.6. I applied the formula of chi-square. Chi-square is summation of I equals to 1 to kth element oi observed value minus expected value whole square divided by expected value, right? So 1.4 plus, then after this I calculated the value of chi-square, which comes out to be 6.6. The value of chi-square is 6.6 and my critical value is 3.84. At 1 degree of freedom, at 95% significant level, the critical value is 3.84 and the chi-square value is 6.66, which means the chi value is more than the critical value. So we reject the null hypothesis. This shows when the chi-square value is more than the critical value, this shows that there is a significant difference between the groups. And when there is a significant difference, we reject the null hypothesis. That is, gender and voting are independent of each other, right? I hope now this is clear to everyone, right? Chi-square test, non-parametric test, right? We'll continue with non-parametric, more non-parametric test in our next lecture. But I hope that this chi-square test or goodness of fit test is clear to you, right? We carry out non-parametric. See, there are two types of the test, parametric test and a non-parametric test. I hope now this is clear. Parametric test, we conduct the parametric, there are certain assumptions to carry out a parametric test, and when our data meets those assumptions, we carry out parametric test, and when our data doesn't meet the certain assumptions, the required assumptions of the parametric test, then we carry out non-parametric test. We can generalize the results of parametric test, but it is very difficult to generalize the results of non-parametric test. Non-parametric tests are less powerful than the parametric test, but when assumptions are not met or there are certain conditions when it is difficult to met the assumptions like the psychological test or market research test, then we carry out non-parametric test. And one of the non-parametric tests we discussed today is chi-square test and KS test, right? We discussed the chi-square test in detail, right? Chi-square test is it is known as goodness of fit test, right? And in this we compare the expected value of with the observed value, and then we find out whether there is a significant difference between the groups or the classes, or there is no significant difference between the classes and the groups. So today we discussed about the coding of data, or we discussed about the mm, non-parametric test, especially the chi-square test. In our next lecture we discuss more non-parametric test. I hope this is clear to everyone now, right? Uh, that's all for today. Thank you very much. Namaskar.